Hello, my name is Trevor and I'm here to talk to you about fiber optics. For those of you who would like to know what fiber optics is, what it's used for, how it works, you have come to the right place. I've got a series of courses that I've put together. They're short YouTube courses, free of course, and I'll be putting them all together that would explain to you exactly how fiber optics work. The first question here is, what is fiber optics? Well, fiber optics is a path which we use to transmit voice, video, or data using glass as the transmission medium and light as the carrier. It is lighter, smaller, and more flexible than copper cables, with faster speeds and greater transmission distances. On the last slide I said that we use light as the carrier of signals through a fiber cable. Well, your next question may be, what is the speed of light? Well, excellent question. And the answer for that question will be, light has various speeds depending on where it is traveling. Light travels through a vacuum-like space at approximately 300,000 kilometers per second. Light takes a bit longer to travel through dense objects. For instance, water. Light travels through water at 225,000 kilometers per second. Glass is a bit more dense than water, so light would take a bit longer to travel through glass. Light travels through glass at 200,000 kilometers per second. Now that you know a bit about how light travels and the speed of light through various mediums, now how we harness that light to get it from one point to another through fiber optics is the next thing that we're going to be talking about. In order to get a light signal from one point to another, we use silica glass to form our transmission path. Silica glass is the purest form of glass in existence. Okay, this is what a fiber optic cable physically looks like. You have an end connector connecting to that cable, which you would plug into the transmitter, let's say for instance, which is sending the light signal, and you have another connector like this on the other end that would plug in to the receiver. Now, a fiber optic cable consists of four sections: the core, the cladding, the buffer, and the jacket. Now, it looks extremely small right now, and I'm sure it's quite difficult to comprehend exactly what these layers are, but just take my word for it. This cable is divided into four sections, and this is what we're going to be talking about for you to get a thorough understanding of how fiber optic cables work. As I said in the last slide, the fiber optic cable is divided into four sections: the core, the cladding, the buffer, and the jacket. Now, in this slide, we're going to be talking about the core. The core is where the light signal travels from the transmitter to the receiver. So this is the light source, and it's traveling along this path right through the fiber cable to the receiver. Now, this is a solid piece of glass. Solid piece of glass, and this light signal just travels right through the core to the receiver. So this is all called the core. Okay, so we're going to be talking about the other sections in the next slide, but I just want you to understand that the light travels from the source to the receiver through the core. In this diagram, we have a light signal going from the transmitter through the cable to the receiver. But as you see here, the cable is not straight, is curved like most cables in the industry are. Very seldom you'll find a perfectly straight cable. Cables can be run in any format whatsoever. It doesn't have to be straight. But light travels in a straight line. So if this cable is curved for any reason, the light signal is going to continue going straight. And this is the core here. Just as we talked about, this is the core. This is a piece of glass representing the core of the cable. Now the light signal goes through the core of the cable and it exits the core and it disappears, and that light signal is lost forever. So this is where the cladding comes in. The cladding sits on the edge of the core on both sides, right around the core, right around the diameter of that cable is the cladding. And what happens is that the light signal, when it comes in contact with the cladding, it is not allowed to go through. The cladding is doped slightly differently and it restricts the flow of light through. So that light is reflected back in to the cable, and we'll be talking about that on the next slide. Now, without the cladding, this is what will happen. The light will just, if it is a straight cable, the light may be able to go right through the middle, right through the receiver. But if the cable is curved for any reason, the light goes in a straight line and is going to exit that cable. So the cladding is very important in order to stop the light from exiting. So we're going to be talking about this on the next slide. On this slide, I have a light source sending a light signal into a fiber cable at an angle. I deliberately drew it this way just to show you exactly what happens when a light source comes into contact with the cladding. The cladding is the area in blue. The core is the area in white in here. Now, normally on a fiber cable, you won't be able to tell the difference between the cladding and the core. They're both glass, so they're both the same. You really can't physically look at them and detect that this is the cladding, this is the core. But the cladding and the core is always there. It's just that the cladding is doped slightly differently in order to restrict light. As I sit down here, the core is made of pure silica glass, and the cladding is also made of pure silica glass with a bit of boron or germanium in order to dope this a little bit differently to restrict light, and just 1% difference is all that's needed. So once this light source comes into contact with the cladding, it is reflected once it comes into contact at an angle more than 90 degrees. If it's less than 90 degrees, it's going to go right through the cladding, just as if the cladding wasn't there. The cladding would not be able to restrict light that is less than 90 degrees. So once it is greater than 90 degrees, it reflects the light at an angle greater than 90 degrees, and it contacts into the cladding on the other side, and this continue happening. Now the cladding is right surrounding the fiber cable. The diameter of the fiber cable is the cladding all around. So it doesn't matter where within that fiber cable the light hits, it's going to be reflected back into the core until it gets to the other end, to the receiver. And this is called total internal reflection, and this is what is needed in order to get a light signal from one end to the other. Total internal reflection, that is just this light signal being reflected from one end to another and is not exiting the cable. It just continues this pattern all the way through, because as I said before, light travels in a straight line. So once it is reflected, it's going to go straight until it is stopped, then it is reflected again. It would never curve or bend or anything, because light travels in a straight line. So this is how we get it to the other end. As I said before, if the light goes in and the cable is perfectly straight, you may be lucky enough to get it right through the middle to the other end, right? But when the cable is bent and change shapes and all that, the light signal do not. So you're going to end up with this. Okay? On this slide, we have the cable we've just talked about with the core and the cladding. We talk about total internal reflection is the way in which the light is reflected right through the cable until it gets to the other end. Now what we have under here is another diagram just demonstrating the additional layers. Now this is showing you a bird's eye view of the cable. Now this is if you look at the cable from the end. And if your eyesight was good enough, like a bird for instance, this is what you will see, the different layers within this cable that represents the core, the cladding, the buffer, and the jacket. Now we talked about the core and the cladding. The buffer is just a protection for the core and the cladding. It just protects the glass. It is material put within the cable to protect this glass. It is just all types of plastic material, for instance, that is stuffed into this area that to stop the glass from being crushed or whatever. It protects it. And the jacket is the same insulation that you will see on the outside of a wire, a copper cable for instance. Now a copper cable will have this same type of plastic kind of material on the outside to protect the cable. So with a fiber cable is the same idea. You will have a jacket that would protect the cable for underwater. If the cable is going to be underwater, you will have a waterproof type jacket. If the cable is going to be underground, you'll have a jacket that will survive the elements underground. So this jacket all depends on what the cable is being used for. So again, you just have the jacket, you have the buffer that protects the glass from being crushed, and then you have the cladding and the core, which is the glass within that fiber cable. And these are all the layers of the fiber cable. This is exactly what you will see within every fiber cable. It doesn't matter what that fiber cable is being used for. These are the layers that would make up that fiber cable. We have reached the end of part 1 of the training. There are many more parts to come. In coming videos, we'll be talking about the different types of fiber cables, like single mode fiber, multi-mode fiber, and their differences. We'll be talking about bandwidth of fiber cables and distance limitations of fiber cables. We'll be talking about laser light sources and LED light sources, and we'll be explaining exactly when LED light sources are used and laser light sources are used. This is just the beginning of a complete fiber training course. In order for you to be able to follow along, just be sure to click the subscribe button below and then click the notification button so that you'll be notified when the next video is released. Thank you for watching, and I'll see you in the next training session.